Alright, so this section we're talking about the guided notebook, guided worksheets on page 37 through page 40, which is most of chapter 3. Chapter 3 deals a lot with units and conversions and scales and things like that. So definition is just a unit that refers to a choice of measurement like kilograms, pounds, milliliters, different things like that. There's different types. There's units of measure or units of observation. So you could classify somebody by their nationality or something like that, or you can have units of measure, which would be like centimeters and feet. Most of what we're going to be doing is units of measurement. So a conversion, we can just set up ratios, which are again those fractions, and set up our different units of measurements to get our conversions. There is a table that you'll see that you would be able to use to help you with this information. Make sure that you copy that information from that table into your spiral notebook. So for this first example, they told you in the directions that 1 kilometer equals 0.612 miles and that 1 mile equals 5,280 feet. And they want you to convert kilometers to feet. So we could set it up this way. We have the 149 kilometers, and we're looking for feet. And we know that 1 kilometer equals 0.6214 miles. So when we cross multiply, we end up with x kilometers equals 149.6 times 0.6214, which is 92.96 miles. So now we need to get from the miles to feet. So we're going to take the 9264 miles over feet and do 1 mile over 5,280 feet, and we end up with 490,836.4 feet. So what we did is we did this in 2 steps. We calculated the miles, then we calculated the feet. So what we're going to be doing some with this is if you look at this, what we're doing is analyzing it by dimensions. So if you think of this as being over 1, and you've got 149 times 0.6214 miles over 1 kilometer, the kilometers cancel out because you've got 1 in the numerator and 1 in the denominator. So then across the top you're left with feet, and the miles are going to cancel out in this calculation. So we're going to be doing some more of that in a minute, and you get the same answer. So question 2 says write down the equation for this proportional relationship between kilometers and feet. So kilometers over feet equals 149.6 over 490,000. So basically if I cross multiply, kilometers equals 149.6 divided by 490,000 times Fahrenheit. And so that would be your formula. Now the next step says convert 149.6 million kilometer to million feet. So million means just simply that you're multiplying by 10 to the 6th power, or you're multiplying by 1 million. So to convert kilometers to feet, you're just going to take the answer that you got for feet and multiply it by 10 to the 6th so that it's in millions, and then that represents that we have 490,836.4 millions of feet. Okay, we don't normally write it out with a lot of decimals, with a lot of zeros, but that's a possibility that you could see. Alright, so question number 4. So this time we're talking about scales. So there's different ways of doing things, like when you scale a model or you use different temperatures or something like that. So in this case we have a planetary scale. So they're telling us that Mercury is 47.9 million kilometers from the Sun, and Venus is 108.2 million kilometers from the Sun, and the Earth is 149.6 million kilometers. So if I wanted to create a model that was realistic, I'm going to set the Earth to 1, and I want to know what would I have to set Venus to and Mercury to. So I set up a proportion, 57.9 over 149.6. That's going to be Mercury over Earth. And then I'm looking for X, which is Mercury. So X over 1, and then when I cross multiply, I get 0.387. Now another way, like if we look at the way we did it on some of the other things, we may set it up horizontally instead. So for example, the 149.6 we might put over 1, and the 57.9 over X. And if we work this math out also, we will still get 0.387. So that means that that Mercury is 0.387 distance from the Sun. We're going to do the same thing with Venus, and we get 0.723. So what exactly does that mean? It means, for example, if I create a scale and the Earth is 1 foot from the Sun, then Venus would be 0.723 feet from the Sun, and Mercury would be 0.387 feet. If I created it and Earth was 1 inch from the Sun on my scale, then the Venus would be 0.723 inches and Mercury would be 0.387. So we call this a unitless scale because basically the units don't really matter. It could be feet, it could be inches, whatever you're trying to do for your scale, you could set it up. Okay? The last thing down here at the bottom of page 38, it says the rate is a ratio between quantities with different units, and the second quantity is scaled to some standard. And we see the word per whenever we do that. So we're going to talk about that, like miles per gallon, things like that. Okay, so here's an example. In 2011, there were nearly 14 million prescriptions written monthly for American adults that were between 20 and 39 for ADHD medications. If there were 82,364,000 adults aged 20 to 39, find the following. They want to know the rate of prescriptions per 100. So the 14 million is the number of prescriptions, and the 82,364 is the number of adults. But the prescriptions is per million, and the adults are per thousand. So we have to correct our scale over here. So we have 14 times 10 to the 6, because that's millions, and 82,364 10 to the third, which is thousands. So when I do my division here, I end up with 0.170. So what that tells me is that 17 out of 100. So that tells me that 17 prescriptions for every 100 adults were written for ADHD medication. So what if I wanted to know the rate per 1,000 adults? Well, 100 is multiplied by 10 to give me 1,000. So that means I would have to take the 17 and multiply by 10 to get 170. So it would be 170 prescriptions per 1,000 adults. Now this next one, to look at your calculator and refresh your memory on this. So on this one, notice that if I take the 14,000 and I divide it by 82,364, notice how I get 0.169977. So when I did problem number 6, I rounded it off. Well, what if I don't round it here and I ask you per 100,000 people? So now I'm looking at 16,997.7 prescriptions per 100,000 adults. So we wanted to keep our decimal places here instead of just rounding it off to 17,000. And which one do you think is best? So this is something that you would have to make a decision on yourself. I like the 17 over the 100 because it really gives us a percent, and it makes sense to talk about 17% of something is happening. People usually understand that. Whereas the 16,997 is actually giving us a little bit more accurate result. So you would have to make that decision. There's nothing to say that you couldn't have made this 16.9%. So you could have made a percentage a little bit more accurate, but that's a decision you have to make. All right, the last thing we're going to talk about is concentrations. And this is a very common thing, especially in nursing or even as a parent, if you're trying to make sure you're giving your child the correct dosage of medications. Okay? So this chart is very important. So you will have this chart on your test because you have your guided workbook. So this chart has a whole lot of conversions. You could possibly go out on the internet and find other conversions. So the first question says, convert the density of water, 1 gram per milliliters, into pounds per gallons. So I did it down here, and I did it a little bit differently than I did it up here. So here I have grams per milliliters. So using my chart, 1 gram equals 0.001 kilograms. So if I put that information in this, if I put the 0.001 kilograms over grams, notice that the grams will cancel out and I'd be left with kilograms over milliliters. Well, I need to get pounds. So I do it again and I come up here and I see that 1 pound equals 0.45359237 kilograms. So I do it this way, pounds over kilograms. And I specifically do it that way so that the kilograms will now cancel out. So now when I do this multiplication, I will be left with pounds over milliliters. So I got the pounds that I need. Now I've got to get gallons. I've got to convert milliliters to gallons. So up here again, 1 milliliter equals, whoops, that's not the one I want. 1 milliliter, actually this isn't on here. 1 milliliter equals 1,000, 1 liter is 1,000 milliliters. So notice that I wrote that next. So my milliliters will cancel out. And then 3.7854 liters equals 1 gallon, and that's up here. So when I write it specifically this way, my liters will cancel out. And so now you'll notice on top I have pounds, and on the bottom I have gallons. So if I just take all these numbers across the top and multiply them together, 1 times 0.001 times 1 times 1,000 times 3.7854, and I take all the numbers on the bottom and multiply them across, and I end up dividing those. I end up with 8.345 pounds per gallon. So you can also do it the way they have here. The only thing that I didn't like about this as much is that they were using some conversions that weren't in the chart. So there were things that maybe you have to know and you may or may not know. So it's up to you. If you understand this conversion and you understand things like 1 kilogram equals 1,000 grams, then you can use these conversions to help you out. All right, and the last one, number 11. So on number 11, the doctor ordered 2.3 grams of Rocephin to be taken by a 15-pound, 6-ounce infant every 8 hours. And the recommended dosage is 75 to 100 milligrams per kilogram. So our first calculation here is converting from grams to milligrams. And then our second calculation is converting from ounces to pound, and then from pounds to kilograms. And we're using the conversions in the chart. So now we have here the number of milligrams and the number of kilograms, and I want to know milligrams per kilograms. So I do the calculation and I get 989.4 milligrams per kilogram per day. Well, that is above the recommended dose.